In this section, you're talking about the antiderivative. The antiderivative is the opposite direction of the derivative. When you had the power rule, remember you subtracted 1 from the exponent. Well, in the antiderivative power rule, you add 1 to the exponent. So here's how it looks. I'm asking you to find the antiderivative of x to the 4th. Your rule at the top of the page says add 1 to it, 4 plus 1. That exponent is 4 plus 1. You also divide by that, and you throw a plus c on the back, which means plus a constant. I'll explain what the c means on the second slide. So if you simplified this, you'd get x to the 5th over 5 plus c. That is the antiderivative of x to the 4th. Now these are super easy to check. The way that you check an antiderivative is you take the derivative of it. So if I take the derivative to check, let's say to check. If I take the derivative of x to the 5th over 5 plus c, here's what I get. I bring the 5 down. I decrease the power by 1. There's already a 5 on the bottom. And the derivative of a constant is just 0. So I would get x to the 4th plus 0, which is what that function was. So that's how you're going to check these. All you have to do is take the derivative of it. Now, what is the c? So if you look at the left side of the page, you have x cubed plus 13, and we took that derivative and just got 3x squared. You also have x cubed minus 21. We took that derivative and got 3x squared. You also have x cubed plus 1/2. You took that derivative and got 3x squared. Now, let's say you went in the direction of the blue arrow. If you actually found the antiderivative of 3x squared. Okay, so you use your power rule that you saw on the previous screen. That would be 3x to the 3rd over 3 plus c. The 3's cancel out, and so that would give you x to the 3rd plus c. This here is called the general antiderivative. Now, looking back over here, the way that I got the 3x squared was I started with a function x cubed plus 13. My next one was the function x cubed minus 21. The next one was the function x cubed plus 1/2. All of those had the exact same antiderivative, the exact same derivative, 3x squared. So when you're going backwards in this blue arrow direction, the c represents any constant stuck on the back. So in the top example, the c would have been 13. And in the second example, the c would have been negative 21. And in the third example, the c would have been 1/2. And you'll say, well, how do you know the c? Well, your Calculus 2 teacher is going to show you how to find c. I am not. That's not part of this course, thank goodness. But in order to find c, other conditions must be given. And in this class, I'm only going to ask you to find the general antiderivative, which means every problem that you see for me in this particular section should have a plus c on the back, which represents the general function, general antiderivative function. Alright, if the derivative is a constant, then the antiderivative is just cx plus d. Now here we have here the number 5. So if you are finding the antiderivative of 5, that's actually 5x to the 0. That's what that constant actually means. So if you're using the power rule for this one, you're going to say that's 5x to the 0 plus 1 over 0 plus 1 plus c. So you would actually get 5x plus c as your function. I use d there on the end, but you get 5x plus c as your antiderivative. So basically, if you have a constant term, to find the antiderivative, you just throw an x on the back. Alright, the next slide that you see are the list of trig antiderivatives. So you have cosine and sine, and then it jumps to secant squared, secant tangent, and cosecant cotangent. Now your first glance might be, why doesn't it do secant? Well, the antiderivative of secant is a very difficult one to do, and so these are ones that are basic and easy to do, and that's why we go with these. When you get to Calculus 2 and Calculus 3, they're going to do much more difficult antiderivatives. Before we go any further, I want to show you the symbol on the back, on the front. That's actually the integral symbol. And that integral symbol means antiderivative. So from here on out, when I ask you the antiderivative, it will have that symbol on there. Now, while we're on this slide, there's one more thing I wanted to show you. What you notice is, on the left side, of course, you see cosine, sine, secant squared. But on the right side, you see your basic trig function. So you see sine, cosine, tangent, cotangent, secant, cosecant. So that's the other reason why these are the only ones listed. These are the antiderivatives of your basic trig functions, sine, cosine, tangent, cotangent. These are the only trig functions that you will be asked in this course. You'll also see that these are not on the final exam. I don't want you to get it mixed up with the derivatives that are on your final exam. They will be on your quiz, but not your final exam. In your next slide, we'll actually start these types of problems.